Brady's walking to the building now. Whatever. There's a ramp on the
Good morning, everyone.
Morning.
Are you ready? No? On Monday you have exam. Get ready.
We don't have to be ready until then.
Okay.
I'm excited.
Last minutes, always.
That's how we get our holidays.
That's how we get the excitement and
Yeah.
the joys.
Oh, okay.
3 months of work in 3 days.
Yeah.
That's what you're supposed to do, right?
I was the same, actually. Unfortunately. Okay, let's quickly solve it because I have a meeting at 10. Hopefully we finish it by that time. No chance, but let's see. Are recording?
If you let me,
Yeah, of course, sure.
we're good to go.
Okay, so first question, we want to plot the boat diagram. And for part A, first things to do is convert it to the standard form, which means I don't need to touch this one because this is a sample, it's a 0 at origin. It's 6, 2, 5, 0, 0, 0, J omega. This is also a standard. J omega over 1. I put 1 to not forget what's going on. This one I have to take 10 out. It's gonna be 10 J omega over 10 plus 1. Here I have to get 50 out, but there is a 2 here. Then I take 50 to the power of 2. J omega over 50 plus 1. This is my equation. There is a 0. This is my first pole, second pole, and the third pole. Whatever we see here, now we can call it K0. Let's plot. We know that it's gonna be a start from 20 log of K0. You have calculator, you can calculate the value. I don't need to do it here. The first frequency is a 0 frequency and a 0. A 0 at origin make what? Plus 20. So it's gonna be plus 20 dB per dk. So we know that here we have a 0. Then I said this is gonna be 1, 10, and 50. This is 0, this is P1, P2, P3. I put a power 2, not forget that the change is gonna be significant. Okay. Help me to draw it faster. So the next thing is a pole here at this frequency. The power of 1 is reduced by minus 20. It is positive plus 20 is going to be flat. Then another pole here is going to be reduced by 20. Here, 2 poles. Now here is 0, this is minus 20 dB per decay. It's going to be how much? We're done. It is a band pass filter. Not easy, am I right? How about this one? This is almost ready. I I don't need to convert them. Unless this part is confusing. You know that j to the power of 2 is going to be negative 1. Here, it is actually j omega 2. That's it. And because it is a standard, not a standard quantity, this 4 is probably problematic. So I take 4 out, divide by 4, I convert this one in 1, multiply it with 4 to the power of 2. Now this is our K0, and we have 0, 1 here at 4. Also we have pole 0 to the power of 2 here. This is pole 1 and this is pole 2. Now I read a lot. Scratch it here. So I have P0 to the power of 2 at origin, then I have something at 4, which is a 0. Then I have something at 10, which is also 10 is going to be P. Actually, this is also to the power of 2. P1 is 1 and 100, P2. Okay, I'm ready to plot it. We start at 20 log of K0. I have a pole here, it's going down. The slope of minus 40 dB per liter. Am I right? Here. Then at 4 I have 2 0. 2 0 is minus 40, add to this. Then it's going to be a flat up to the next. After that I have one pole at this. That was minus 40, it's going to be a little bit like this. Then at 100 another pole. So this is minus 20 dB. Okay. Minus 40 dB. And this is 0 dB. It's a low pass filter. Yeah. The next one, I have to take these 2 out. Then it's going to be 1. 40 out is going to be 1. And again, this is J omega 2. 100 out is going to be 1. So this is a 2, a 40 is going to be multiplied with 80. By 4 is going to be 40 is going to be 80 multiple, and this is also 100, but the power of 2 is going to be 100 to the power of 2 more. So this is going to be my K0, and there is Z1, Z2, P0 to the power of 2, and P1 to the power of 2. Here is the information you need. So at 0 we have P0 to the power of 2. Then the next one is 2 0, 1, then 40, it is 2, sorry, 0, then 40, 0, 2, then 100, P, 1, 2. So this is 100 upper. It is 20 log of K0 and 2 poles come like this minus 40 dB per decade. Then I have 1, 0 and 1, 0 here. It's gonna be up to here. And after that it's gonna be flat. And after this 200 like that. It's minus 20 dB. Decade 0. Minus 40. Done? Easy? Okay, you want to find the hj omega transfer function from this both plot. We have to find the K0. K0 is going to be something like that. It's going to be 20 log of Kz. But we don't know the value. From here we can calculate it because decade is matter. The slope is dB per decade. At 10, you see it is 0 dB. For 1 decade, it's gonna be 20 log. Okay? You may wonder why I don't consider another 10, another 1 here, because this scale every time getting smaller and smaller. So comparing with this, you can ignore it. Unless specifically mentioned that. Because this is a feature of logarithmic plot. So then from here to here is how much? 20 dB per decade. It's gonna be 20. Then the value here is how much? Negative 20 dB. So from here, K0 gonna be, we divide everything by 20, it's gonna be 10 to the power of minus 1. I said K0 to K0. Agree? Which one of these? Equation gonna be hj omega 0.1. So what I have P0, sorry, Z0, because it is a 0, it's going up. It is 1 0 here. Then you reduce to 0. At here I have P1. At 10, I don't have anything. That information only used for finding K0. Here, I have another 0, I call it 0, 1. Then again, one pole, P2. And here I have 2 poles, P3, 0. It's 2 actually. The 0 is at origin, J omega. The next one gonna be J omega over what? The next is this one, Z1 at 20. Then I have 1, 2, 3 poles, which the last one is the power of 2. J omega plus 1. J omega plus 1, J omega plus 1. And the first one is 4, 100, 600. 4, 100, 600. Done. The next one is very similar. Again, this 10 given to find the initial value. Initial value is going to be something like this. It's going to be 20 log of K0. What is the value here? 40 dB. Everybody agree? So 40 dB. Then K0 is 10 to the power of minus 2. Am I right? Yes.
Wait, where did you see 10 to the power 2?
Correct. Plus 2 side. It's gonna be 100. Hj omega equals 100. I have 2 poles at 0 at origin. Then I have 1, 0 here, and again another pole here. Am I right? So it's gonna be 1 J omega plus 1 here. At origin I have 2 poles J omega 2 and J omega plus 1. Okay, the first one, the first 0 is at 5, and the P1 is at 50. We want transfer impedance or generally transfer function. So there is no initial values. We have to transfer it to the Laplace. It's going to be 1 over S. It's going to be 4 over S. It's going to be 5S and done. It's going to be VOS. This is the first circuit in Laplace. So, what is the easiest way to solve this? The best way, I guess, is that finding current division between these 2 branches. Then we have the current of this branch. We multiply it with 4 is going to be V4. So this is, we call it I1, then I2, 1 equals IS, I ignore that parenthesis S, simplifying, IS multiplied with the impedance of the other branch, am I right? So impedance of the other branch is 2 plus 5S plus 4 over S divided with this impedance plus the impedance of the 2 plus 5S plus 4 over S. And the impedance of this branch is plus 1 over S plus 4. Okay, this is this current. If I multiply everything by 4, the result is what? VO. So I need what? VOS over VS. Then I divide everything by IS and IS. Then my VO over IS equals to what? This value is going to be 8 plus 20 plus 16S. I multiply 4 with these 3. These together going to be 6. This going to be still 5S.
You forgot to put an S after the two. On the numerator, it's gonna be 8 plus 20S.
Yes, thank you. Yes, and this gonna be plus 5 over S. If I multiply everything with S, it's gonna be 20S2, I restore it plus 8S plus 16. This is gonna be 5S2 plus 6S plus 5. This is a transfer function. So find impulse and step responses. The transfer function itself is what? Impulse function. Because impulse, if instead of this one, you put the impulse current, the in Laplace is going to be 1. Then the voltage you calculate here is going to be impulse response. You can convert it to the time domain. If instead of this S, I put 1 over S, it's going to be a step function. Then this 1 over S multiplied with this 1 over S. Then when you find the Laplace, inverse of Laplace inverse of this one, you calculated the step function. So we practiced a lot to how to convert the Laplace inverse at a time domain. So let's rest of time. Everything is clear, am I right? Super clear. VO over VI, another transfer function. In Laplace, this is going to be S done. Here also is going to be S. How to solve this one? So first of all, we can put these two together or get rid of this one. Then we have 2 loops. So we have 2 loops. We can write 2K here. or it's better to find the voltage here. We call it Vx. We know the current here. It's gonna be VO over R. Multiply it with this impedance, it's gonna be Vx. Vx is gonna be VO over R by R plus Ls. This is that voltage. Then I will write a KCL at that Vx node. The current going the other way is gonna be Vx minus Vi over Ls. The other current is Vx over 1 over Cs in parallel with R. And the last current is gonna be VO over R. So if you put Vx here and here, you will have one equation with Vi and VO. You have to play it, put it in a different, put the Vi and V out in different location of the different side of the equation, then divide by Vi, you find VO Vi. Clear approach? Or you want me to do it? Like this, do it, it takes time.
If we have time to come back to it.
Oh yeah, I would love to do that.
Can we,
You can come back.
can we go through the rest
Yeah.
and then come
Yeah,
back?
let's do that.
Yeah.
How many left? 4 left? I will do it. Okay. First, I will take care of this one, R CS over 1 over CS plus R. The result is R over R CS plus 1. Okay, I will put this one. Then I will, it's better not simplify that, just put it there. It's gonna be VO with R plus LS. Just follow my calculation. If I made a mistake, correct me, okay? Vx over R divided by Ls plus VO over R plus Ls over R over what? R over RCS plus 1 plus VO over R equals 0. So this VI over Ls, I take it to the other side, there is going to be what? Plus VI over Ls. Agree? Then I can get rid of that. But on this side, I take out all the VO. VO multiplied with everything. This is gonna be R plus Ls. This R goes down, LRS. For this one, it's gonna be this R gonna be multiplied with this one, and this goes up. This is gonna be R2, then R plus Ls multiplied with RCS plus 1 plus 1 over R equals VI over Ls. I divide everything with VI. VI, this can be cancelled, there gonna be V out. And I divide everything with this. Correct?
In the exam, can we just leave it? Like, do we have to simplify all those fractions? Or can we leave it like that?
So if you leave it like this, I will give you the full score, because at at this level, I realize that you understood what to do. So let me see the final, not final, but the better version of that. VO over VI gonna be what? This is apparently 1 with LS multiplied with this R plus LS over LRS plus 2 parentheses over R2, not R2, R to the power of 2, plus 1 over R. So this is R plus LS RCS plus 1. Correct? This is a transfer function. If you write something like this, it's okay. But you can kind of multiply everything with R2. Up gonna be R2, this part is gonna be gone, this gonna be R. R2, 1 R gonna be gone, with this one, the other is gonna be R. See, this is not that much also difficult. I can multiply everything with, I don't need, I multiply this LS inside that, this gonna be cancelled, then VO over VI gonna be R2, this gonna be R2 plus LRS, multiply it with this one is gonna be plus LS with these 2 parentheses repeated plus LRS. This is also R plus LS, RCS plus. You can multiply this easily, gonna be simplified. What is challenging? You are gonna be graduated soon.
It just takes time.
It's a lot of letters being shifted around.
I agree that it's parametrically is difficult, but if you had numbers instead of LC, it was much easier. I wanted to challenge you.
I definitely
That
felt
is-
challenged.
We can tell.
I thought challenge.
Louder.
In second equation, Vx minus Vi over L is, how we got V over R? V0 over R? No, V, yes, first one, I was first one. Before, V0 over R in the second equation.
V0, V0 over R here.
Yeah,
So this is the current here, Ohm's law. This is the current in this and this.
so why we are not including SL? It should be R plus SL, right?
When you want to find the voltage of Vx, yes. What is the voltage? You have the current in this branch and you have the impedance. Impedance is what? R plus Ls. Then the voltage is gonna be that current. So Ohm's law. This kind of problem, if you have difficulties, you know what is the reason?
We did pay attention in class.
No.
We're bad at algebra.
No.
We're dumb.
Ohm's law.
Ohm's law is not
It was a
bad.
good guess.
Because you just started processing that. You don't go one step back and look at that, what can I do? Just really a little bit, think about that and then do that. So if you look from a little bit away, if you are inside that, you cannot solve anything. But if you go back, you say, I can multiply it with this or I made it a bit one step simple, one step simple. Then everything will be easy. this, they call it reconsideration in general. Everything you do this reconsideration. Okay? For any successful people, you will see that they are good at this. Whatever you do, you just think about that. Okay? In a long period. For example, this year, what I did. Something like that. There were a kind of a short video that one person, a man asked his son to go and bring someone to repair or make a wall in the yard. And when said the son to do that, he said, make sure you bring someone that smoke cigarette. Son said, okay, why? What? He said, because every step he finished, I want he go back and take a cigarette and look at what he has done. Okay? This is important.
Should we bring cigarettes to the
Not
final?
I don't encourage that, but that was the kind of way that, yeah, you remember this example. Because of that I mentioned bad things.
So she's told us we can disrupt.
Thanks for the pack, everybody.
Really helpful to my classes.
Circus, what do you see here? What?
Negative pass.
Oh, it's too soon.
Negative feedback.
Negative feedback.
The voltage is 0 and there's no current as well.
Okay. All of things that we need is there. The voltage here, which we call it 0, is going to be copied here. This is also in Laplace going to be 1 over S. Then this is inverting amplifier. The gain gonna be V out over V in. Gonna be negative. The impedance at the top, the impedance at input, because the voltage is 0, I can say that. If the voltage wasn't 0, you had to calculate the current and the current, put them together, same thing. But right now, because it is 0, it is easy for me, just say that. Value is gonna be R2 in parallel with 1 over C2S over R1 plus 1 over C1S. Done. Because we need it for the next step, we simplify it again. So I will do it here. It's gonna be R over C2S R2 plus 1 over C2S R1 plus 1 over C1S. This is actually the things that I ask you to do. Just look at that, what you can do, what is the best things to do. This C2S can be multiplied with this and cancel this one. Then let's do that. R1 plus 1 over C1S. It's going to be R what? R2 over C2R2S plus 1. I can multiply everything with this C1S and also take this one at the lowest. So it's going to be C1R2S, then this is going to be C1R1S plus 1, and this part is C2R2S plus 1. What do you see here?
Standard one.
Not a standard yet.
Oh, a 0 and 2 volts.
0 and 2 poles. So P1 and P2. Okay, I can guess what's gonna be the shape. Am I right? It's gonna be a start here first. I have a 0. It's going up. At the second frequency, let's assume this one or this one. I don't know which one happens earlier, depending on the values. But at one of them is going to be 0. The second one make it. Now you can say band pass. But let's simplify it a little bit better, completely convert it to the standard form. It is kind of a standard, but let's make sure about that. Instead of C1 R1, I can say, in form of frequency, I can say S1 over C1 R1. Then this is gonna be frequency now. Frequency of 1 over C1 R1. Okay. This one is a standard, but I put it down there. It's gonna be S over C2 R2. Am I right? 1 over C2 R2. This is gonna be FP1. This is gonna be FP2. Now, because this is a standard, this is what? K0. Now I can say it is K0. For R1, R2, C1, C2, put the values, and then you can find exact values here.
And then, if that can be the maximum, in the
Yeah.
PowerPoint, to find the maximum gain, it was like R2 over R1, I think in the slides.
That was another problem. You change a single component. That wasn't for band pass filter. That was low pass filter. It was the ratio of that ratio. Check that.
So whenever we're finding the K0, we always just convert it back to standard form, just to,
If it is the standard, that
okay,
that is the case.
okay.
So I'm sure that you don't have any problem to multiple two numbers and put the exact values.
You would think.
At this point, I feel like,
I can do basic. Just wait till we shake
I
that
feel like I
test.
have a
Wait
lot
till we
of
take the
problems. Is that one just the same thing?
Almost empty, yes.
Okay.
But
And it's gonna
that's-
look the same?
I don't know.
Okay.
We'll see.
It's interesting.
According to.
Let's see. Apparently it is similar.
That's the standard form. Like that's
Okay, you see here, it's gonna be S, it's gonna be S, we are done, everybody here, V out, over V in. Ryan, you come late, and you talk a lot. When you ask question, I cannot hear you, but when you talk with your friend, I hear you. Okay. Don't forget negative, I forgot the negative sign here, and negative sign here, sorry. This one is gonna be R2 in parallel with L2S, R1 plus L1S. Instead of this, I can say that it is R2 over R2, L1, L2, L2S, over R2 plus L2S. So apparently this one, it is R2, L2S, R1 plus L1S, R2 plus L2. Yes. It has again 1, 0 here, 2 poles. The shape gonna be something like this. I put the values for L and R, L's and R's, so you can find exact frequency and K0. Now the K0 this time. Oh, wait a second. For K0, I need to process it one more step. So First of all, I have to divide everything by R1 and R2, okay? So let me continue. The result is gonna be, if I take R2 here, with this one gonna be cancelled, then it's gonna be L2 over R1, I put it there, then it's gonna be L1 S over R1, even I put this S here plus 1 now, then it's gonna be L2 over R2 S plus 1. Now it is a standard form, but the frequency, I take this L under R2, then everything gonna be fixed.
And so the,
If I write it like this, S over R2 over L2, and we do the same thing here, S over R1 over L1, then this gonna be what? Now K0, this is the standard. This is F of P1, F of P2. I don't know which one happened earlier on that plot. After you find the value, you can say which one, maybe F P1, F P2. The smaller goes here would be here goes. Yeah. Standard form, then you can compute.
why do we put the R over the L instead of?
Because we want to have the standard form J omega over something, am I right?
And so it's, is it,
You remember we write 400 J omega over J omega plus P 1 plus 1. You remember this format? So, Nico, you asked, do you remember this format? So we want to generate this format. Put something here, but here, the factor here, index is 1. Should we say S is J omega? So to generate this format, we say R1 over L, or R2 over L.
why would it not be the L1 over R1? Because would it not just be 1 over L1 over R1? And then, does that give us, okay.
These are the same.
I'm just,
What you said,
okay, I'm really confused.
those are same. Okay, in this problem, find the transfer function V out V in, and that's it. Transfer function. So finding the transfer function, yes, split everything. It is gonna be Vx. You calculate the transfer function in the first stage. Then we assume that Vx is the input of the second stage, then we calculate.
And it's just the same as the last two, right? Each of the.
And then we
the
multiply
individual
them
ones.
by each other.
Then multiply.
I think I did. This one felt the easiest.
So Vx over V in is how much? Jake? It is the inverting, okay? It's gonna be negative,
So it's gonna be the impedance over the amplifier on the, in the numerator, and then the impedance at the.
100 in parallel with 100 over S, agree? In Laplace, this gonna be 100 over S, this gonna be 4S, 1 over 4S, 1 over 2S. So that's the impedance of top branch, and the impedance of the input is 1 in parallel with 1 over 4s plus 1 over 2s. Agree? Then V out Vx is what? Again, another inverting amplifier, negative. The impedance in the top, this is gonna be 10 over S, and this gonna be 2 over S this time, and 4. The first one is gonna be 120 in parallel with 10 over S, and the input is gonna be 4 plus 2 over S. You have this. If you multiply these two, it's gonna be Vx over V in multiplied with V out over Vx. This is gonna be cancelled. The result is V out, V in. So equals to negative gonna be cancelled with the other negative. The result is gonna be multiple 100 over 100 S 1 over 4s, then plus 1 over 2s. 100 parallel with 10 over S and 4 plus 2. I believe you can simplify that. It's not gonna be difficult. Very good timing.
4 minutes to solve the last question.
Okay,
It was a very easy question.
question. Jake, you are happy, it's good.
Jake's not.
This one also is the easiest one. Garcia confirmed that. She wants to calculate the voltage of super position. Negative feedback. Then it means that the voltage here is how much?
6 volts.
6 plus. There's gonna be one current here, one here, and one from here, very important. Then all of them together, I1, I2, I3, I4, IF. Because the current here is 0, all of those 4 current goes here. Then if I write the KCL here, IF equals I1 plus I2 plus I3 plus I4
And then this is just when you set the.
instead of I4 should I write what? Ohm's law. Consider the direction. It's gonna be 6 minus V out plus 6 minus V out over 100. I1 is how much? 9 minus 6 over. Then 10 minus 6 over. How much? 20.
And this one's gonna be negative 12.
The other one is gonna be negative 12 minus 6 over 30k plus what?
12 minus 6 over
0. 0 minus 6 over 30. high school level equation to find VR. So in high school you practice this kind of somewhere a little bit. Okay? So you can find V out, and that was the last question. See timing?
Perfect time.